Hey! Today we're looking at 7.3. This is going to be completely new to you guys today. All right? And we kind of alluded to this a little bit in 7.2, but we know the inverse operation of addition is subtraction. We know the inverse operation of division is multiplication. Okay? We kind of alluded to the fact we need to figure out the inverse operation of exponents. Well, today we're going to figure it out. It's logarithms, okay? Logarithms is how we undo exponential problems, okay? And what I want to show you is how these two relate to each other. So the problem on the left, the blue line here is an exponential model, okay? Exponential model. We have y equals 2 to the x. And that should be clear from our work yesterday, all right? This next case is a logarithmic model. Remember, with inverse operations, all we do is switch the x and y, okay? So looking at these two, they are indeed inverses of each other, all right? Notice they're a reflection over that line y equals x, right? But these are two separate models. They undo each other, okay? So exponents and logs are inverses of each other, all right? We're going to look kind of at the definition here, all right, of what logs are. So log base b of x equals y if and only if b to the y equals x. If you notice, the bases are the same. Base of the log is the same, the base is the power. The answer is your power. All right? And then what you're logging is the same. Okay? So if log base 3 of 27 equals y, then 3 to the y equals 27. We can use this information to help solve. All right? So the first thing we're going to do is look at this. All right? Write each equation in exponential form. So this is logarithmic form. We want to write it in exponential form. Remember exponential form, we have a base, we have a power, we have an answer. All right? Remember, the base of the log is the same as the base of the power. The 4 comes into play. The answer is your power, and then what you're logging is the answer. So 4 squared equals 16. And hopefully we understand that that does make sense. So 4 squared is 16. That's the same as log base 4 of 2. You can kind of ask yourself when we're evaluating logs, 4 to what power is 16? The answer is 2. Okay. Same thing's going to happen here. So we have a logarithm base 3 of 181. We want to write this in exponential form. So we have a base, we have power, we have an answer. All right. So my first step, the base is going to be 3. The base of the log is same as the base of the power. The answer is my power. All right. And then whatever we're logging is my answer to the exponential equation. All right. 3 to the negative fourth is 1 over 81. 3 to the fourth is 81. A negative exponent. Oops. Base, power, answer. Keep in mind, as we log things, we're looking for the power associated with those two numbers. Okay? It's important that we not only know how to go from log form to exponential form, but also to go from exponential to log form. So we're going to start here, and we're going to transfer this back into log form. So I'm going to need the base, I'm going to need what we're logging, and I'm going to need my answer. Just like before, the base of my log and base of the power should be the same. All right? My power is my answer, and then the answer to my exponential function is what? We're logging. So the log base 5 of 125 is 3? You're thinking 5 to what power is 125? 3. Okay. We can do the same thing in this situation. I'm going to start kind of stripping things away. Log base, in this case, 4. Right? Base of the power is same as the base of my log. What I log is my answer, which is 1 over 256. 4 to what power is 1 over 256? Well, hopefully we know that is negative 4 based on that. So again, hopefully transferring back and forth between forms is easy. It makes sense. Again, we kind of have to shift our mindset a smidge today. All right. Some of us can't think in logs. So if it helps you, you can transfer between forms. So you could almost think 3 to what power is 81. All right. If you can't think in that log form, write it in exponential form so you can figure it out. And in this case, your answer is 4. Hopefully, as we go through some of these problems, you're starting to see how we can have calculator and no calculator portions of a quiz. All right. We're trying to kind of get you to think about things, use those mental math skills to come up with answers so we don't have to rely on our calculators for everything. Right? The next problem here, again, if we can't think in logarithmic form, we can write it in exponential form. So I'm thinking 1/2 to what power is 256? Well, I know that 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8th is 256. But since I flipped it, my power would have to be negative. All right? And that's how we evaluate logs. You can either think in log form or exponential form. Either way, you're going to get the same answer. All right? The second part of the day is going to be graphing logarithmic functions. Okay, there's a couple ways to do this. You can graph in log form, or you can graph using exponential form. Keep in mind with logarithmic graphs, since they're inverses of exponential function, my range is always going to be all reals. The domain is what's going to be limited. Okay, and we're going to have vertical asymptotes on our graphs. Okay, it's kind of the opposite of exponential functions, which makes sense. So we're going to go through the 2 ways to figure out these problems. All right, method 1 is using that log form to figure things out. Okay, so I'm going to create a table of values, and I'm just going to come up with things. Keep in mind we have log base 3. All right, so kind of the easiest thing to think about is 3 to the 0, 3 to the 1, and 3 to the 2. 1, this is 3, and this is 9. Okay, so we want to kind of keep the powers of 3 in the back of my mind. So the question is, how would I get that to be a 1? Well, if x is 0, 0 plus 1 is 1. Log base 3 of 1 is 0. Right? 3 to the 0 power is 1. Okay? So 3 to the 0 power is 1. That goes away. So that's a 0. 0 times 2 is 0. 0 minus 4 is negative 4. Okay. We go on to the next one. Question is, how do I get my log to be a 3? Well, if I plug in a 2, 2 plus 1 is 3. Log base 3 of 3 is 1. 3 to the first is 3, right? So log base 3 of 3 is 1. 1 times 2 is 2. 2 minus 4 is negative 2. All right? The next power of 3 we want to use is 9. Okay? So the question is, how do I get a 9 under there? Well, it would have to be x value of 8. 8 plus 1 is 9. Log base 3 of 9. 3 to what power is 9? 2. All right? So the log becomes a 2. 2 times 2 is 4. 4 minus 4 is 0. All right? So I could use those points, 0, negative 4. 2, negative 2, 8, 0. And then I can graph my problem from here. All right, so that's using our log form. You could also use exponential form if it helps make a little more sense of things. So what we do is we'd have to move everything over. Sorry, I'm going to get that out of the way so you can see the problem a little better. All right, so we'd want to write this in exponential form. So we're going to move the 4 over. All right, we're going to divide by 2. So essentially what we have is y plus 4 over 2 equals log base 3 of x plus 1. All right, keep in mind base, power, answer. So I know that 3 to the y plus 4 over 2 equals x plus 1. And then what I can do is bring 1 over equals x. So the difference in this form is now we're going to plug in y's to get our x's, right? And since we're dividing by 2, I'm going to pick some nice values. So I'm going to pick negative 4 because that's going to give me a 0. 3 to the 0 is 1. 1 minus 1 is 0. Okay. Then I want to pick multiples of 2. So I'm going to go 2 to the left. So we have negatives, or sorry, 2 down because we're talking y values. Negative 6 plus 4 is negative 2. Negative 2 divided by 2 is negative 1. 3 to the negative 1 is 1/3. Minus 1 is going to be negative 2/3. Then I'm going to go 2 the other way. Negative 2 plus 4 is 2. 2 over 2 is 1. 3 to the first is 3. 3 minus 1 is 2. Notice, did we get the same coordinates with either form? Yes, we just got a different third point, which is A-OK. All right? Keep in mind, it is important that we establish our domain and range on these. Our range, as we said before, is always all reals. The domain, what are we thinking as we see this? Remember, with exponential graphs, our asymptote and range was related to our k value. So it would make sense that with logarithmic graphs, where we switch the x and the y, that our asymptote is related to our h value now. And if you notice, it works out perfectly. Our x values have to be bigger than negative 1, which does coincide with that h value. Right? So again, I don't care if you use log form or exponential form. Exponential form is a little more work because you have to transfer forms. Just remember you're plugging in y's to get x's with that exponential form. If you're using your logarithmic form, you need to think about the powers of that base in your head. In this case, we were thinking of the powers of 3 in my head, and then we figure out x's to get y's. Your assignment's there in the bottom. Again, there is a worksheet with some more graphing logarithmic problems attached. Make sure you complete both. If you do have questions on any of these, please let me know. Otherwise, enjoy the rest of your day. Great seeing you. Seeing everybody.